All right, so my name is Bobby Boyles, and this is the title of my project, A Comparison of Cretaceous Paleogene Boundary Sediments from South Carolina and North Dakota. And I worked on this project with Dr. Adam Smith over at the Geology Museum. Okay, so sort of as an introduction, the KPG boundary was produced when an asteroid hit the Earth around 65 million years ago. And that's when this asteroid also is what is hypothesized to have killed the dinosaurs. But basically, this asteroid left a geologic indicator in the form of the KPG boundary, which kind of appears as just this kind of layer of ash and dust that's kind of anomalous, and people didn't know why it was there for a while. And so people started looking into it, and they figured out it was an asteroid impact that produced that. So in this project, I'm looking at this KPG boundary in both North Carolina, or not North Carolina, South Carolina and North Dakota sediments. So one of the main things that I was looking for when I was kind of examining these sediments under a microscope is shocked quartz. And shocked quartz is quartz that has been put under a very high temperature and pressure for a short amount of time, or hence shocked. And the way that this manifests itself is kind of these lineations in the quartz. You can see on the picture here, got these crisscrossing lines, and that's what makes it shocked quartz. It's the temperature and pressure that produces this shocked effect. Another indicator of the KPG boundary is microspherules, and basically what happens here is material that was vaporized when the asteroid hit the Earth, like the rock and the dirt and all the stuff that was under it, gets vaporized, and as it cools and condenses, it cools into these little spheres, basically, because as it's falling back down to Earth from the sky or space, it kind of just cools, and as it's falling, it spins kind of like a raindrop, so it's spherical as it cools. So that's why you get these little sphere shapes. In the picture here, you can see the white spot in the middle. That's one of my microspherules that I found in one of the North Dakota sediment samples that I have. So I thought that's pretty cool. This is under cross-polarized light, and it's not extinct right now, as you can see. So, yeah, pretty cool. So my methods, the first thing I had to do was collect a sample from a KT boundary site in South Carolina, and I did this at a sand mine near Columbia. So I did that first in the summer of 2019. I got that sample, took samples from it, and brought them back here to Clemson. And then North Dakota's boundary sample had been obtained previously by a field trip that the Geology Museum had done a few years ago. So I had already had access to that. After I had gotten the samples, the first thing I had to do was cut them down to billets to fit on a microscope slide so I can look at them through the petrographic microscope. So I cut them down to billets and glued them to microscope slides. This rock saw is what I used to cut the rocks down to size so they'd fit on the microscope slide. And then after that, we started the long process of grinding the billets down so that they could be thin enough I could actually look at them under the microscope. This took a long time, and I wasn't able to finish it because of COVID, so we had to send them off to a company to be completed. And so once I got those back, I was able to start looking at the samples under a petrographic microscope, which I'm sure you're all familiar with in the mineralogy lab. You can see I was using the one that had the camera on it so I could take pictures of what I saw. I was using this petrographic microscope and looking at the slides under various magnifications and different light. So kind of the biggest thing was I was looking for extinction, because there's kind of this clay matrix that the quartz and the microspherules kind of sit in. So I had to, and there weren't like tons of microspherules or quartz or anything, especially shocked quartz. It was kind of hard to find, but I used extinction as kind of an easy way to spot that sort of thing quickly. So that's what I did with that. And you can see in the picture here, I'm using You can see this quartz grain. This one's not shocked, but you can kind of see what I was looking at. And obviously, if I'm looking for extinction, I need to be using cross polarized light, but I also used normal light to kind of see what they look like under to the naked eye, if you will. So yeah, that's what I have so far.